Here we have the digital multimanometer. In the bottom left corner, we have the power button. This will turn on the unit. The unit will need 10 or 15 minutes to warm up and stabilize the value. Note that the range of this is plus or minus 20 inches of water column. So this should be converted to pascals or PSF when doing calculations. This is a multimanometer because it can measure multiple pressure ports. So let's take a look at how this works. This is the boundary layer experiment, and this is the boundary layer rake. The pressure that is felt at each one of these tubes gets transmitted through the soft tubing, and this soft Tygon tubing is connected in the back to this pneumatic switch. Okay? There is one pressure transducer in the unit, and it's going to measure the gauge pressure, meaning it's measuring the pressure at this position in reference to the atmosphere. And you can see that this is what we call a differential transducer, meaning it's measuring the difference in pressures. And this is the other tube, which would be measuring the ambient temperature of the room and therefore giving us the gauge pressure. After the value has stabilized, again, it might take 10 to 15 minutes, what you're going to want to do is turn this knob here, which is the zeroing knob, and you can bring the value close to 0. Okay? And plus or minus 0.002 would be a pretty good range here. Okay? So what you can see is we have the multiple tubes hooked up in the back. And if you look on the back, you'll see that each of the tubes is numbered. Let me see if I can show you that. So here you can see the number 20, the number 0, and it keeps going around. So you see this would be tube number 0, 1, 2, 3, all the way around. And so that's going to allow you to then know what pressure you are measuring by just changing this dial here. And so if you want to measure the tube or the pressure that corresponds to tube number 1, you would just put this at 1, and the screen will then show you what that value is. It's pretty stable at this position because we don't have any flow going through our wind tunnel, but during an experiment, you may see that this number would vary significantly because of the unsteadiness of the flow. So to get an accurate result for the data, we're going to take a time average of that signal, and we can do that by running the signal from this manometer through this wire here, and it goes to the computer behind the small wind tunnel. There will be a separate video showing you how to collect the average from this manometer.